had a project idea that I wanted to execute, so this would be like one of many parts of the project itself. So the very first thing that we'll have to do is open up Proteus and create a new project. So the first few minutes of the video itself is all about creating the project itself, finding the right directory, putting the project itself in a folder, making sure that it's tidy. Yeah. So that's just like the intro of the video itself. But of course, if you guys don't know how to create folders in Windows using shortcuts, you can just press Control Shift and N, and then you come up with a folder. So that's just the very first part of the video itself. Is just trying to make sure that everything is in place and make sure that everything is neat. So I think this part is not really important. So the components which will be needed for this project are the Arduino, the IR or infrared, and the logic state itself, which is help us to toggle between false and true, because we can interact with the simulation itself. So those are the most fundamental components we're going to need. And I also decided to make sure that the components themselves are close to each other, just to make sure that the zooming in effect is efficient enough. So the IR itself has 3 pins. That's the out, which is just like the signal, and then we have the GND, which is the ground. We have the VCC, which is voltage common collector. Voltage common collector. So the VCC itself takes on 5 volts. That's the reason why I'm plugging it into the DC voltage itself. And I decided to use pin number 3 itself as the means of the signal itself when it came to the IR itself. So that was just the basic circuit itself. So we also need to have a virtual terminal itself to help us out to see whatever is happening in terms of communication between the Arduino and the computer itself. So that needs to be there. Now we need to come up with a code of the system, make sure that everything is right. So this is just me coming up with a valuable initialization. And pin mode basically is just saying that configuring if the specific pin should be an input or an output. Serial begin is all about initializing the serial communication, initializing serial monitor communication between the Arduino itself and the computer. But in this circumstance, it's the simulation and the computer itself. So now the if statement itself is there to help us check if there's an action being taken on the IR itself. So if there's an action, that means a certain type of event should occur. So I'm going to use the serial monitor itself to print out a few words just as event that should happen once the IR itself has been triggered. So that's the statement itself. So I just decided to copy that and paste it over there. So whenever an object passes, or an obstacle rather, gets in front of the IR itself, what actually happen is that I do increment. We had I think number of objects plus. So that itself will just help us count the number of objects that have passed by the IR itself. So this part I was just coming up with the name of the project itself. So the next thing is to take the hex file of the Arduino and make sure that you paste it in the directory of the Arduino program file, so the Arduino itself should break down the code, right? So as you can see, the part it also crashed there because I didn't have the hex file for the IR. Luckily enough, I had it in my PC, so I'm just trying to find the directory of the IR file itself. And if you try again, I think everything's fine. So you can see the visual terminal itself is printing out numbers. And for this part itself, the English wasn't fitting right for me, so I just had to change up a few things, make sure that everything is fine. The English is definitely that. So after changing up a few things, let's go back and let's see. So number of objects. So let's give it 5 volts to make the IR operational. And as you can notice, as I'm toggling the logic state itself, the numbers were changing. But the numbers themselves were changing so fast to the point that I really couldn't see the change. So I had to add delay just to make sure that the numbers were changing in comparison to the number of times I actually clicking the logic state itself. So I needed those two to be in line with each other. As you can see, at least here they're changing, but not very fast at the first one. So I had to change it to 750 milliseconds to finally come up with something which is relatively close to the number of clicks that are being done on the logic state. So I decided to add one more component, which is the buzzer, just to make the project a little bit much more fun and interactive. So the buzzer itself will be going off or will be triggered as soon as an object stands in front of the IR itself. Now the buzzer itself, the default settings for the buzzer itself is that it has 12 ohms, which is really small, so I had to increase that to 1000 ohms just to make sure that enough current is going to the buzzer to trigger it. So in this part itself was just initializing the buzzer itself, making sure that the buzzer has an output in terms of the pin mode itself, and also making sure that the buzzer itself receives 5 volts if and only if there's an object in front of the IR itself. But if there's no object in front of the IR, the buzzer itself will not be going on, it will just be quiet. So this is what I'm basically doing on this part itself. Yep. Of course, in the very first attempt, it didn't work because I forgot to change the pin mode from input to output for the buzzer itself. So you can see there was no sound coming from the buzzer itself. So I had to change the input to output, make sure that everything is fine, compile the program again, go back to the simulation, and as you can hear, the buzzer itself is going off. So that's the sound of the buzzer. Until next time.